Hi, I'm Mrs. Burns and welcome to lesson 5.2 on salts. So we have already learned about acids and bases, and when you put those two together, they will actually react to form a salt and water. So here we have our little equation, acid plus a base come together to form a salt and water. There's another way to make a salt though. You can also form salts by the reaction between a metal and an acid. So an alkali metal plus an acid will give you salt and hydrogen gas. An alkali earth metal and acid will give you salt and hydrogen gas. Notice the difference here between water and hydrogen gas. So what are salts? Well, some examples, we see calcium, iron, and magnesium in the form of salts in our multivitamins. Also, there's classic table salt, salt and pepper. That's NaCl, in fact. We find salts in multivitamins and batteries, explosives, fertilizers, French fries, and in the wintertime, we put salt on the roads to lower the freezing point. When an acid and base come together to form a salt and water, we call this a neutralization reaction. We already learned this last day, that when an acid and base come together, they neutralize each other. So for example, hydrochloric acid, it looks like this, HCl, and because it's an acid, we know that this must be dissolved in water, so it must be aqueous, plus sodium hydroxide, NaOH, combine to form sodium chloride and water. Beautiful. So here is our acid, here is our base, and this forms our salt and water. And one more time, just to remember that this is an acid, we've got the H at the beginning, the hydrogen positive ion, and we have the OH at the end of this guy, the negative hydroxide ion. So what about if we don't know what they form? Well, you are going to get to use all those skills you learned in chapter 4 about naming, and you're going to get to change some of the places and rearrange the dance partners here, and it will really help if you are familiar with not just the periodic table of the elements, but again, which elements are multivalent, which ones are polyatomic ions and such. So in this case, we are going to form a salt and water. So we see already here H and a couple O's, so we're probably going to make H2O somewhere. So Al, this is our metal, so it will go first. And this gets confusing, so I know that this part and this part are probably going to go together because the H2O is going to go together over here. So SO4 and Al. Well, if we look up SO4 and Al in our data booklets, we'll see that SO4 is a 2- and Al is a 3+. And that makes sense because this 3 went down there and this 2 went down there. So it's Al SO4, and if we swing down the little switcheroony here, it will be at, oopsies, I have it in the opposite direction. It will be Al2 and SO4 3. Plus water, H2O. Now let's check, are we balanced here? We've got 2 Als, well we've got to make 2 Als over here. We've got 3 SO4s, so we have to make 3 SO4s here. We've got 6 plus 6 is 12 H's, so we need to put a 6 here to make 12 H's, and then 4 times 3 is 12 plus another 6, 18, and let's check here, 12 plus another 6, 18. Beautiful. Now metals and acids also can come together to form a salt. However, they don't form a salt and water, they form a salt and hydrogen gas. Now remember that to be in the gas form, hydrogen doesn't like to be by itself. So if it's a gas, it'll always be H2. That is just something that we understand in an equation. If you see oxygen by itself, if you see hydrogen by themselves, they will pair up. They're those special 7 that we looked at in chapter 4. So the alkali metals And the alkaline earth metals are the most reactive metals. So they're the ones that we're going to be checking out here. Of these two groups, the elements at the bottom of each group, the bottom row, are the most reactive. So if you look at your periodic table, which one is lower down at the bottom of the table? Is it potassium, K, or Rb? Well, we see that Rb is more reactive. And in this case, Fr is more reactive, Sr is more reactive, and Ra is more reactive. So remember that these guys chomp the bigger value. So we show that the ones along the bottom of the table are the most reactive elements. All right, what about hydrochloric acid and a magnesium strip? So this is an example of a metal and an acid. So hydrochloric acid, that's HCl, aqueous, plus magnesium strip would be just solid magnesium. They react to form, so you want to do your arrow to show the reaction, to form magnesium, chloride, and hydrogen. So if you just see hydrogen by itself, you know it's hydrogen gas, so it's going to be H2. And we also have to check out Mg2 plus and Cl minus, so this should be Cl2 here because these switcheroo down to here. So this would be like Mg1 Cl2. So is this balanced? We have one magnesium on each side. We need to get two chlorines on this side. Now we have two hydrogens. That is balanced. Beautiful. Now, on to the back, there are also some other things to consider called metal oxides and non-metal oxides. That's when a metal and an oxygen come together, or a non-metal and an oxygen. So an oxide is a compound that has an oxygen element in it, within that compound. So because Na2O has an oxygen in it, we call it sodium oxide, and that is a metal oxide. So a metal oxide has a metal and an oxygen combined together. When they dissolve in water, it makes a base. This is really neat. So our metal oxide plus water creates two sodium hydroxides, which is a base. So when a non-metal, however, and an oxygen combine together, this is called a non-metal oxide, and this, combining with water, will create an acid. So sulfur dioxide and water will combine to form sulfurous acid. Let's try a couple together. Here we have calcium oxide, so this is a metal oxide. This forms with water, so we're going to make something that we know is going to end up being a base. So if you look up how they could form together, you might see that we can get, this will be aqueous, calcium hydroxide. And one of the tip-offs that you will see is that because this is a metal oxide, we're going to make a base. And hydroxide, that is indicating that we have a base present. Remember that the hydrogen is acid and OH hydroxide is base. So if you see hydroxide, calcium hydroxide, you know that must be a base. All right, let's see this one. Here we have just a regular old salt being formed because we have an acid and we have a base. So they're going to make a salt and a water. So always the metal goes first, NaCl plus H2O. So the NaCl will be aqueous, it will be dissolved in water. This is balanced already. Beautiful. So this is sodium chloride. And this one is a base. This one is a salt. Last but not least, here we have a non-metal oxide, CO2. So they are going to make an acid. So how could these two combine? Well, because it's going to make an acid, we're going to put the H first. And we see that we can have H2CO3 aqueous, which is carbonic acid and is an acid. All right, I would like you to look at pages 234 to 243 of your textbook. It's got some really cool stuff in there, all about the uses of salt, some really crazy things about salt, and some cool stories that we're going to get to talk about tomorrow in class. So please come prepared to dive into this a little bit further.